Welcome back to Math 103. This is video number 15 on voting. We've been looking at some questions about Arrow's theorem in order to pin down our understanding of what it does say and what it doesn't say. So question number 1. If someone devises a voting method which never violates the majority, Condorcet, or IIA criteria, then what can you say about the voting method? Well, according to Arrow's theorem, the method must sometimes violate at least one of these methods, then it must sometimes violate the one remaining fairness criterion, namely the monotonicity criterion. Next, suppose that someone dreams up a voting method which never violates the majority, monotonicity, or IIA criteria. Right there, before you even look at the rest of the question, immediately it follows, well, if it never violates those three fairness criteria, it must sometimes violate the one remaining one, the Condorcet criterion. So we go into the remaining parts of this question with that in mind. Our voting method, whatever it is, must sometimes violate the Condorcet criterion. So we look at question A. An election is held, and there is a Condorcet candidate. So we have in mind, our election sometimes violates the Condorcet criterion. So a particular election is held, there is a Condorcet candidate. What can we say about this election result? Well, actually, we don't know. We can't actually say that much because this is just one particular election using this voting method. There is indeed a Condorcet candidate. A single election, that Condorcet candidate might win or might lose under this method. But now, if you apply this same voting method to many different elections, each of which has a Condorcet candidate, then eventually, in one of those elections, at some point, you're going to have a Condorcet candidate who loses. This distinction between what eventually happens and what happens in a single election is crucial to understanding what Arrow's theorem does say and what Arrow's theorem does not say. Finally, we consider a pair of true or false questions. The first one goes like this. Suppose that you read about a recently invented voting method which never violates any of the four fairness criteria. Then the author must have been mistaken about the voting method. True or false? This statement is true. Arrow's impossibility theorem says that exactly this is what's impossible. So whoever wrote this must have been mistaken about what the voting method can really accomplish. Next true-false question goes as follows. An election is held using a certain voting method. At least one violation must have occurred. Well, that is false. There is no reason why in one particular election a fairness criterion must have been violated. Arrow's theorem doesn't predict that a violation has to occur in every single election, not even close, even though that is a common misinterpretation of what it's saying. We have reached the end of our study of voting theory, and after carefully defining and working with several voting methods and several fairness criteria, we see that the subject is actually much more complicated, much more subtle than we would have imagined before we had approached it mathematically.